So through our use of AI, we're able to eliminate a lot of noise, have very tighter bands, and then our advanced AI are able to narrow down things and decision making very, very clearly. But I gave you all of these examples, and these things can, be all over the place. But essentially, then we kind of boil it down to saying, hey, ticket number one, if you have to do one thing today, go check out clipping at this inverter because this is losing you these many units of energy. And that list is completely prioritized.
Today on the Clean Power Hour, advanced data analytics for solar asset management. My guest today is the CEO and founder of Quadrical. Welcome to the show, Sharat Singh. Nice to see you.
Thanks, Tim. Great to be here.
We're here at SAMNA, the Solar Asset Management North American Conference, and in Oakland. And we were chatting a little bit in the pre-show about your start, but share that with our listeners. How did you get interested in data analytics? And then tell us a little bit about the story of Quadrical.
Absolutely. Tim, throughout my career, I have been at the helm of building large enterprise solutions for e-commerce and other industries. In the most recent stint, I was senior vice president at Adobe, building a large data platform for their customer data platform, which is a big data analytics system. About 2018, I met up with my co-founder, Hugh Hine, and between the two of us and our third co-founder, Kitty, we realized that there's a massive gap within the industry in terms of how the AI systems are being built. When we initially started out in 2018, we were thinking of a horizontal system which would serve a variety of different use cases for AI, specifically in the field of pattern recognition and anomaly detection. Through the course of meeting up with customers, we realized that there's a massive gap of how these technologies are being used in the forefront of what is happening globally in terms of renewable and clean energy. So about middle of 2018, we decided, about middle of 2019, we decided that we want to pivot our overall software capabilities towards the solar industry. And that's how we are building a platform for the solar industry.
And what all were you involved with at Adobe? Because obviously, big company, many products, best known perhaps for Photoshop. But tell us a little bit about your background there.
Oh, absolutely. So Adobe has three different lines of products. One is the document system. You would know about PDF. Second is, as you said, the digital systems. And the third is their digital marketing cloud. So given my experience at e-commerce, I was focused on the digital marketing cloud. Okay. And I was managing a team of about 700 engineers based out of our India head office, which was focused on having a slew of different products capabilities supporting the overall digital marketing cloud.
Now, your company, Quadrical, is based in Toronto. Tell me about that. How did you settle in Toronto, and what was the ideation behind Quadrical?
Yeah. So Quadrical is, we're kind of based in two different geographies. We have an office in Gurgaon, and we have an office in Waterloo. Waterloo is a student town, and it is the town for University of Waterloo. My co-founder, Hugh Hine, is also based in Waterloo, and since we needed a strong technology backbone, we believe that leveraging the combination of skills and talents in Toronto/Waterloo, combined with the overall scale of the platform we want to build in Gurgaon, was a great combination. So those are kind of the reason as to how to focus and build sharpened AI capabilities and innovation out of Toronto/Waterloo, as well as large scalable systems and platform and teams out of Gurgaon.
Okay. And it sounds like you almost stumbled upon the solar industry. Who was that customer, so to speak? You don't have to name them by name, but if you can, do. And now, what are you up to?
Our pivotal customer who kind of guided us through our early days was a company called Solar Arise. Their co-founder, James Abraham, he's again one of those visionary founders. They manage, they're an IPP who's been managing and growing a platform about 250 megawatts. They helped us learn significantly about the solar industry. And they also challenge us every step of the way to sharpen our product, not just to be an analytics platform, but something which can create a quantifiable impact to the overall capabilities and the yield of the platform. Since then, now have a total portfolio of about 2.5 gigawatts. We have some of the largest customers in terms of not just the IPP space, but also the O&M space. Through that experience, our product is battle hardened in the field. We have tons of use cases which are most impactful to our customers. And then through the course of last couple of years, we've been able to add significant AI capabilities in the arena of not just being able to improve yields through what we call condition-based maintenance, but also add specialized use cases around soiling, shading, anomaly detection, and a whole bunch of other capabilities leading to predictive maintenance, where our customers are able to manage their assets in a much more proactive manner than what they've been used to in the past.
So this is under the umbrella of performance monitoring, and analytics, right? And so are you actually deploying sensors in the field, or are you just getting data from somebody else's sensors?
Excellent question. And again, a lot of people have that general question as to what does a product do? So just to kind of give you a brief 5-point things as to what all things that we do. In the area of data acquisition, we're able to pull the data, not just from your SCADA system, from your data loggers, from any of the APIs from vendors like Also Energy, Meteo Control, InAccess, Isotrol. So we're extremely good at the data acquisition where we have our own drivers to be able to pull that data. Secondly, once the data has been pulled, in the cloud, we're able to do all the ETLs, the standardizations, and all the data harmonizations. Third, and most importantly, once all of this data is there, we're able to create our digital twins, exact replica of your plant in the smallest component of instrumentation that you have. This allows us for extreme amount of precision and granularity. Secondly, it allows us to be able to create what we call a condition-based maintenance capability. And third, most importantly, it translates into revenue prioritized tickets, which help you improve the yield of the plant. Once these three things are done, subsequently, we have additional layers in terms of the AI capabilities, as I said, about soiling, shading, historical twins, which help you understand as to how what is their true asset quality over the course of several years that you may have been running the plant. And fifth, and not the least, is our ability to provide what we call remote operations centers, which becomes a center of excellence. We are able to share all of our learnings from our previous experiences. We are able to allow and speed up the adoption within the customer site. And thirdly, it gives us and the customer a lot of regimen in terms of being able to coordinate the discussions with the O&M fields on the ground, create valuable label data, and in the process, create the virtuous cycle of AI, which helps and learns from all the data that we're collecting. So through these 5 different things, it gives them an immense platform for overall growth and ongoing improvement.
Very intriguing, and that is the digital twin. And I understand, at a very high level what that is. You've got your solar farm, and then you've got a model of the solar farm, which is the digital twin, right? But tell us, what all does that entail, and what is the process of creating a digital twin?
Excellent question. So typically, let's just take a 50 megawatt plant. A 50 megawatt plant may have, let's just say, about 22.5 megawatt central inverters. Each one of those central inverter may be connected to another 20 SCBs. Each one of those SCBs may be connected to another 10 strings. More often than not, given how industries are, at the most IPPs would have configured the instrumentation down to the SCB level. But that still means about 400 SCBs or about 4,000 strings. So depending on how the plant is configured, we actually create a digital signature of each one of these 400 SCBs of 4,000 strings. So we have in the simplest of manner, we'll have about 400 digital replica of each one of the personalized SCBs and behaviors, 20 inverters, and then subsequently the various nodes within the plant. The way we configure and create these digital twins, so there's not a single digital twin, it's a full topology of the plant and the corresponding granular digital twin. This is why I meant it's very granular. It's not like one single digital twin. Okay. Now, once I have these personalized understanding of each one of the digital twins, we are able to understand as to what the expectation from each one of these individual digital twin would be under any weather conditions going back into time based on the data available. So once you're able to create the benchmark of what something is supposed to produce, then it becomes rather trivial to say, given the current weather condition, what should each and every one of the nodes should be producing. Once I know that, the very simplest of step in terms of condition-based maintenance becomes rather easy to be able to say, hey, this particular unit is not performing as expected under these conditions. And from that point on, we have built additional layers and capabilities to ensure that those signals can be translated into actionable tickets and revenue prioritized actions for our customers.
Okay. And so this digital twin is then it's there in the cloud, and then you're getting a signal from the field about what's going on in the array in real time, and then you're doing some comparison, right? And then you're getting a signal about, okay, these strings are operating as expected, these strings are operating at less than expected. And then what are you able to discern from that information that's relevant to what the asset manager is so interested in?
Yeah. So these, I think you got everything absolutely nailed perfectly. With that process, the next thing that we're able to do is literally give you, for example, a prioritized list of tickets. So we'll tell you, look, I don't know whether you know it or not, but inverter number 5 has had this much amount of clipping over the last 24 hours. We can go down to the next level and saying, from whatever we can see, string number 45 is seeing excessive shading for the last 20 days. We can go down further. Looks like if you look at the section of the plant related to SCB 48, I'm just throwing out these numbers to be very precise and granular. It is the seasonal tilt on these panels is wrong. Another section of the plant, the tracker is not tracking as effectively as it should be. All the way up to the plant level saying, looks like the paranometer angle is not appropriate or is not calibrated properly. Going back to the, right down to the string level, we can be saying, hey, look, there's some kind of a insulation problem happening in this particular area. There's an MC issue or a Y connector issue on these particular areas. Further down, you told me that the capacity of this particular string is 40, but looks like you have a panel missing, go check it out. So whether it is, or whether certain strings are short-circuited or certain other things. The reality what happens in a SCADA system is you almost have a Boolean and a threshold, which you have to manage fairly carefully in terms of not allowing too much noise if the thresholds of alert is too tight. But we're able to create these thresholds, as I said, to a very, very granular manner. And through our digital twin, we are not suffering as much with the noise in the instrumented systems as a lot of the SCADA systems are. So through our use of AI, we're able to eliminate a lot of noise, have very tighter bands, and then our advanced AI are able to narrow down things and decision making very, very clearly. But I gave you all of these examples, and these things can, be all over the place. But essentially, then we kind of boil it down to saying, hey, ticket number 1, if you have to do one thing today, go check out clipping at this inverter because this is losing you these many units of energy. And that list is completely prioritized. So depending on your own cost and benefit, which things are actionable, which things are not, you may say, hey, look, I do know there's a table shading going on for that shading issue that you're talking about. There's no point fixing it. Versus saying, hey, I don't know anything about why should that particular section be shaded. And you may find that there's grass or vegetation. Actually, we've had scenarios where a customer has insisted there cannot be shading in an area. And as you can imagine, in a large area, there's a honking tree out there. so, so again, we've seen interesting things where the data tells its own undeniable, unrefutable story. So
Yeah, plants can grow surprisingly fast.
yeah.
And whether it's weeds or woody plants, can become a problem. Absolutely. So I'm curious though, where does AI come in, and how does the model learn over time? Because you obviously want the model to get better, and so tell us a little bit about that process.
So as you were saying, right, the statistical systems are, everybody's used to statistics, right? So you can take a full plant, you can say, hey, yeah, right, thank you, Mr. Quadrical. I know my plant is split into 400 different SCBs or 200 different, whatever the count of SCBs are. And I can run my own statistics. I've been running it in an Excel for a long time. And I can figure out what the average performance of each one of those things are. The AI goes much beyond that point. It is no longer looking at the average. As I said, it treats each one of those 400 units individually. It has unique expectations from each one of those based on what the actual installed capacity is, what their manufacturers or their configurations or understanding of how it has performed over the last 6 months or a year. So the key part about the AI, again, in the most simplistic model, which is what we have as a condition-based maintenance, is the accuracy and precision and granularity of the individual models. We create that data model based on the historical performance of not just those 400 units, but the entire plant topology. And beyond this, then there comes the next layer of anomaly and pattern recognition related to, as I said, we can, as we have signatures of how soiling behaves, as we have signatures of how shading behaves, how insulation has the voltage current patterns. So all of those patterns and models, we have base models of those, and then we are able to, as we see these condition-based maintenance issues come up, we're able to run it through a second filter, which helps us narrow down exactly the type of problem that we're seeing.
Yeah. And so, in the greater scheme of things, how accurate is the digital twin, and where is this, where is the industry going in this regard?
So, most of our customers, again, struggle with saying, hey, I don't know how to attribute 500 things which are going on in my plant, right? I have soiling going on in my plant. I have, rather expected degradations from my equipment. I have, the weather conditions are not really well understood ahead of time, whether it's my parameter, which is bad, or whether it was a bad day, whether I have micro weather conditions going on into different parts of the plants. And then, so given all of these noises, people are kind of managing their plant kind of gut wise, saying, hey, look, I got X percentage of PR and that should be good enough because I don't really have any actionable insights. Whether it is big data or AI, it is able to kind of automatically say, look, I understand your plant. I have learned everything that I've learned. Now I'm on auto mode and I'll tell you all the signals that are worth actionable and you can take it from there. So it kind of elevates the game of the O&M and the IPP to a completely different level, right? So they're not guessing and chasing after made up opportunities. They have a very, very clear defined sets of things going. So this, and again, I think with more and more data being collected from our different locations, the core digital twins are getting stronger and stronger. So right now, the way we are is our system is fairly advanced. Now, you believe it or not, we're trying to dumb it down so that we're able to get to our customers and do deployments faster. So where we are right now is, where we want to be is literally that you sign up on our site, you give us an API to whichever system that you're using, and within a day, we should be able to give you a full audit of what happened and what is happening in your plant today, which is actionable. Once you do that and you're satisfied with that, within a week, your plant should be ready to go live on our platform. So we're trying to kind of get to saying what creates the most value of the advanced stuff that we've built that gets you going immediately. where I think a lot of customers do struggle is in the industry, we sell the vision of what can happen, and they're just kind of saying, look, I don't need all of that. Get me going, start creating value immediately, and then we'll see where that goes. So we've had tremendous success in making a complicated product. We're simplifying it, deploying it much faster today, and then combining the PV side of the business with the storage side of the business is where we see a massive value. As of today, we don't see many technologies or companies having any reasonable model on the storage side of it, and we've made some very early preliminary progress in being able to deploy our digital twins technologies to the solar side, to the storage side as well. So I believe that's where the future is going to be, in these hybrid models of solar and storage, and maybe some wind as well.
Hey, everybody. Thanks for listening to the Clean Power Hour or viewing it on YouTube. We do have a great YouTube channel. If you're not subscribed, please go to cleanpower.group and hit that YouTube icon and subscribe to our channel. Of course, you can find all of our content on your favorite audio platform as well. So please give us a rating and review. Back to the show. Yeah, storage is so good for the grid, and renewables are so problematic for the grid that we all want there to be a lot more storage on the grid for a whole variety of reasons. But when you think about solar and storage farms, which eventually they all will be that, right? Today, there's a lot of just solar out there. Tomorrow, it's both and. What are the challenges? What are the opportunities?
No, I think the biggest challenge or the opportunity, so the biggest opportunity, as you very well said, right, is the renewable by definition is, it's for all the good things, it is rather unreliable. And storage creates that reliability. Similarly, in terms of the grid friendliness of storage, it allows you to release energy as and when you need, as and when it is profitable. The biggest challenge with storage still is it's fairly early days in storage, in terms of knowing what the state of the health of your storage is, knowing what the cycle time cost of your batteries are. It's still a little bit heuristic and not very data driven. So we believe that the combination of, similar to how we've kind of solved the noise in the PV side, as we solve the uncertainty or ability to understand the storage better, as we solve those, the combination is going to create similar value for our customers.
But from a monitoring perspective, is you indicated that you could onboard a new customer literally within 24 hours of getting an IP address to their monitoring system. And is storage no different, or is there a different process?
The processes are the same. And the good thing about the whole SCADA industry, and the good thing about everything industrial that we've done in the renewable space, is the basic monitoring systems are pretty much the same, right? There are fairly robust sets of companies which have been building monitoring systems, and it become monitoring and SCADA systems. And it's fairly easy for IPP to kind of pick and choose any vendor. The monitoring from a storage is just another sets of tags and attributes which are slightly different from the similar tags from the PV side. So the good thing, which is obviously helps us significantly, is there's significant traction and significant ability for monitoring. So what we do is build the next layer on top. So for us, we will be able to build on the shoulders of all the work, hard work the industry has already done in the SCADA and monitoring systems. So long answer is we should be able to leverage the same capabilities for storage as well.
Yeah. And so today, if I'm using also energy, and tomorrow I add Quadrical to the equation, it's simply that I'm getting a lot more nuance. So you're augmenting the information that's available to me as an asset owner or an O&M provider. Is that the long and short of it?
The two things where, for the right reason, industries always try to not compartmentalize, but try to create diversification of vendors. So whether you are from a from a monitoring perspective, you may have in-access in one location, you may use isotrol in another location. So there's a little bit of SCADA diversity, and there's a little bit of the monitoring diversity that they've used in the past. Then you end up acquiring different assets, and right, things continue to evolve. So for one thing, our platform is able to integrate your monitoring system across different different assets. So whether you're using also in one area, material control in another area, or for the utility side, whether it's isotrol or in-access, our system is able to give you a comprehensive view across. So that's one side. And then each one of these systems that I mentioned are fairly decent at monitoring. As you said, the second level we're able to do is take the data from a plain monitoring perspective to an advanced analytics, ticket-driven overall portfolio management, both from a plant perspective and in a case of C&I from a fleet perspective. So just being able to combine the portfolio and give you a holistic view of your entire capability, both from the PV side as well as storage side, becomes fairly powerful.
I'm very intrigued. I wish I could spend more time with you, Sharat, but in the sake of time, tell our listeners how they can reach you and learn more about Quadrical.
Fairly simple, cvj at quadrical.ai. And our site is quadrical.ai. And as you mentioned, we would love to talk to you no matter what monitoring capabilities that you're using today. We would be able to show you what a real advanced monitoring AI-based system can do within a couple of days. And then we'll leave it to you to figure out as to how to evaluate the new insights that we've given in terms of what's happening in the field and what has happened in the past. And then, if all goes well, your platform could be on the new AI systems within a week's time.
Wonderful. Well, thank you so much for being here. I'm Tim Montague. Let's grow solar and storage.